Good evening. The today's classes starts from the unit 3, the performance of composites. So already we have gone through many of the things related to the performance of composites. The first one is the strength required for automotive and aerospace applications, and second one is the strength to weight ratio. Among that, the fatigue and fracture toughness, and impact toughness, and crustworthiness. So up to that, we have studied many aspects related to that the performance of composites, which most probably used in automotive and aerospace applications. And apart from the other parameters, which is going to be deteriorate the performance of the composites for the entire duration of their applications. The most important thing is corrosion and wear properties. And one more property is of water absorption and flammability and lightning protection. So what is corrosion? How it is relatively affect? So these are the three parameters we are going to be discussed hereafter. So among that, the corrosion and we are going to be studied today classes. So what is corrosion? So I think we have seen about the metallic corrosion. So this is a metallic corrosion. So the metallic corrosions are known well by many of the applications because most of them we are using a metallic materials. So these materials are used in various applications, especially in for the last decades, and many of them in made up of metallic materials, especially for the steel structures. The steel structures are corrode very easily because of its electrochemical reactions along with the environment. So apart from when we are joining the two different materials, the galvanic corrosions also take place due to that atomic variations between the two metals which are all joined together. So the metallic materials undergo the specific corrosion rate due to an electrochemical reaction. Because of this, it is possible to predict the life. So from the appearance, we can easily understand about that whether we need to be make any maintenance or repair work for the particular application. Or periodic maintenance also we can able to know well. But in the case of a polymeric material, it's not so easy to know about the corrosiveness of the material and the corrosion rate because it purely depends upon the various accelerating mediums or accelerating agents. So this is not the case with the polymeric material similar to the metallic materials. So plastic materials do not experience a specific corrosion rate. It means we can't able to identify when the failure going to be takes place. That way, the corrosion rate is not being identified for the polymeric material. They are usually completely resistant to chemical attacks or the deteriorate rapidly. So even though the plastic materials are chemically retarded, but it can also deteriorate very rapidly because of other reactions. They are attacked either by the chemical reaction or by the solvation. So what is solvation? The solvation is the presentation of the plastic by a corrosion which causes a softening, swelling and ultimate failure. I think this picture we can able to show something related to how the polymeric materials are getting corroded. So the corrosion not only going to be deteriorate the property of the materials, at the same time it not creating some more appearances. So apart from the property decreases because of some reactions is also called as a corrosion. So we can't able to compare with that metallic materials to the polymeric material corrosive rate. So it can be affected by the heat, it can be affected by the UV radiation and the ozonic and the environmental pollution also. So now it can be classified in what way? Depend upon the attacking mechanism. So what are the attack mechanisms it followed during the corrosion of plastic materials or plastic and its composites? So disintegration or degradation of the physical nature due to the absorption, permutation, solvent action or other factors. So in a case of a metallic material, we can able to know the corrosion is takes place only because of an oxidation of the material. If the ferrous is oxide with the ferrous oxide, the corrosion is takes place. When there is a two different material, it will creating the galvanic amount of corrosion. If there is a welding between the two materials, the corrosion takes place because of two dissimilar materials. But for this case, even for the polymeric material of the same structure, It also going to be affected in a case of disintegration or degradation of the physical nature due to the other factors which is called as an absorption, permutation, solvent action, and some other factors we are going to be discuss what are these factors. So oxidation, where chemical bonds are attacked by means of an oxide, and another one is actually called as an hydrolysis, where ester linkages are attacked, and the third one is actually a radiation and thermal degradation involving depolymerization and possibly repolymerization process. As especially in the case of thermoset and thermoplastic polymers, these degradation is most prominently affected the performance of the polymers. So thermal degradation and depolymerization, and some more time it may be a repolymerization. And dehydration, it not very rarely happen, but it also going to be affected for the natural fibers, impregnated polymer composite or natural composites. And any among the combination of various aspects also going to be take place in the case of corrosion behavior. So what is the main result of this corrosion of plastic material of based on this attacking mechanism? Results of such attacks will appear in the form of it will soften the material or charring the material, crazing or delaminating or decolorization or dissolving and swelling. So many of them we can experience with the help of using a polymeric material in your day-to-day applications. Okay. And the first, I will take it about the radiation, because the radiation creating the greater impact of the polymer application, while because it is mostly used in the various weather-oriented conditions, especially in automotive applications or for any other application. It can be used for in different weather conditions. So polymeric materials in outdoor application are exposed to the weather extremes that can be extremely deleterious to the material, the most harmful of which exposure to the ultraviolet radiation. So still we have an idea about what is an ultraviolet. Ultraviolet radiations are not only affecting the polymeric material, all the human beings get it affected by means of ultraviolet radiation. And this radiation is also going to be changed with respect to the weather conditions, the summer, winter, and other rainy season. Also, it is going to be affected, and this ultraviolet going to be changed in wavelength. The wavelength is also be very much important because these wavelengths are greatly affect that polymeric materials, which can cause the embrittlement, padding, surface cracking, and stuff. So it's creating embrittlement. Simple example is, I think you are using the plastic pot in your home. If you are keeping this part in a prolonged period of time in the summer conditions, or where the sun rays are falling on that continuously, so after a certain period of time, it loses elastic effect and it is become so brittle in nature of plastic. The simple example is, if you are using the plastic part for planting something in outdoor conditions, so it will deteriorate in its colors and it become a brittle. That is because called as embrittlement or padding or surface. These are also comes under the category of corrosion of polymeric material. So most plastics, after being exposed to the direct sunlight for a period of years, exhibit reduced impact resistance, lower overall mechanical performance, and changes in its appearance. So this is the causes for the radiation of the polymeric material. Okay, and I think this figure may indicated about all aspects. This is actually called as a crack or embrittlement band. This is a surface deterioration or surface cracking, and this is something called as a chalking. Like a blowing effect, it can be created, and it may be fading. Fading is not going to be shown here because of same image is the color of black and white, and for surface cracking and chalking. So all of them take it the figures in the cases of an aging of the polymers for a period of time. Okay, and ultraviolet wavelength is play an important role for the corrosion of polymeric material. So what is ultraviolet? The electromagnetic energy from the sunlight is normally divided into UV light, visible light, and infrared energy. The infrared energy consists of wavelength longer than the visible red wavelength and stays above 760 nanometer. Among that, it also can be divided in many aspects, starts from 400 to 760 nanometer. The UV light of A grade or A is taken as 400 to 350 nanometer, and UVB is 350 to 280 nanometer, and then UVC is 280 to 100 nanometer. Among this, the 400 to 315 nanometer wavelength is most dangerous for creating the more amount of polymer damages. And 350 to 280 include the shortest wavelength at Earth surfaces causes severe polymer damage and most probably absorbed by the window glasses. And UVC is 280 to 100 is filtered by the Earth's atmospheric found only in the outer surfaces. It's not creating much more damages for the polymeric material. So the two lengths, one is between 400 to 315 and for 315 to 280 is creating the damages uh, um, in the polymeric material. So, and how it is degrade the property of the material, in what way it is going to be degraded, and what the effects is created for the polymeric material. It is creating the photochemical degradation is caused by the photons of light breaking the chemical bonds. The polymers are made up of the chemical CH bond. These chemical bonds are going to be get break by means of photochemical degradation. So the photochemical degradation is caused by the photons of light breaking the chemical bond. For each type of chemical bond, there is a critical threshold value of wavelength of light with enough energy to cause the reaction. In order to break the chemical bond, we need some energy. That energy is only because of the critical threshold wavelength of the photochemical reaction or photon energy from the UV light, and only for the particular wavelength. So light of any wavelength shorter than the threshold can break the bond, but longer wavelengths of light cannot break, as similar to the visible light. Light cannot break the uh, bond, that is chemical bond of the polymeric material. But longer wavelength of light cannot break it regardless of the intensity. Even though it's so bright, it not making any harmfulness to the polymeric chain. Therefore, the shortest wavelength of cutoff light source is of critical importance. So we need, if a particular polymer is sensitive only in the UV light below 295 nanometer, it means the solar cutoff point, it will never experience the photochemical degradation observed. Okay. So the resistance, in order to increase to avoid the degradation with from the UV light sources, some of the selected polymers already have the resistance. Some of them we need to be incorporate the resistance by means of utilizing the stabilizer. The ability to withstand the weathering depends on the polymer type and which grades of the particular resins we are using. The many resin grades are available with UV absorption additives to improve the weatherability, and however, the higher molecular weight grades of the resin generally exhibit better weatherability than lower molecular weight grades. It means the higher molecular weight grades of resin generally have better weatherability than the lower molecular weight. In addition, some colors are also creating the better weatherability. This picture, this table, which will indicate about what are the various polymers already have the resistance to the UV degradation, and some of them we need to be stabilized with the help of the stabilizer from the UV protector. APS, it's a plastic, it would need to be improved by means of introducing the stabilizer. PVC, most probably the PVC, we know that very well about that. Polyvinyl chloride and polyvinyl tetrachloride. So these are them already have the resistance. So the things, many of them still used in various applications like piping of materials and for transmitting the liquid through the various locations. So the pipes, normally the PVC pipes are most probably used in the various applications because of its high resistance to the UV degradation. And similar for other things are also going to be used in many aspects for improving their UV degradation with the help of the stabilization, right? And the next one is very important thing, which is called as permutations. So until that we know about how the corrosion of the polymeric material takes place in terms of radiation effects. But for here, the permutation is creating some other effect for corrosiveness of the polymer. So all materials somewhat permeable to the chemical molecules, but plastic materials tend to be an order of magnitude greater in their permeability than metals. The gases, liquids, or vapors will be permutate the polymers. The permutation, what is permutation? Permutation is a molecular migration through the micro voids either in polymer, if the polymer is more or less porous, or between the polymer molecules. In neither cases is they attacked by the polymer. This action is strictly a physical phenomena. However, the permutation can be determinal when the polymer is used to be a light piping or the equipment. So this is the permutation get affected by means of any of the materials which may be in the form of gases, liquids, or vapor is easily migrated through the microvoids presented in the polymeric material, and then it deteriorates the effect of polymer properties. So what is the result of permutation of various form of materials? The failure of the substrate due to the corrosive attack to the polymer chain, and bond failure and blistering resulting from the accumulation of fluids at the bond when the substrate is less permeable than the liner, or from the corrosion reaction products if the substrate is attacked by the permeation. And the third one is the loss of contents through the substrate and liner as a result of eventual failure of the substrate in unbonded lining. The space between the liner and supporting members must be rendered to the atmosphere not only to allow the minute quantity of fermion to escape but also prevent the expansion of entrapped air from the collapsing the line. So these are the cases for because of the porosity of the polymeric composite material. The form of various materials can be permutated inside to weaken the structures by means of various aspects. One is by failing the substrate material, or by failing the bonding, or by introducing the reducing the supporting material strength. Okay. And this tables which will indicate about the permutation or normally measured in terms of gram per 100 in 24 hours of observation. So it may be varied with respect to the temperature also. The temperature also play a role for a permutation. 73 degrees Celsius and 86 degrees Celsius, or 23 degrees Celsius and 30 degrees Celsius we are considering. So the gases which can easily permutate to the only one material we are taking as PDFE. It is a fluorochloro material, and carbon dioxide will not be permutated, helium is not permutated, only actophenone, benzene, carbon tetrachloride, ethyl alcohol easily permutated on that. And for 86 degrees Celsius, with the increase in the temperature only, the carbon dioxide, helium, and other aspects can easily permutate. And one more thing, in the form of liquid, the liquid also can be considered in the permutating material, which can also reduce the property of the material while it is absorbed by the polymer composites. Then the PVC have 0.05% 24 hours 73 degrees Celsius which absorb the water molecules. The similar way, all other polymer materials are permitted the water in the respect of temperature of 73 degrees Celsius Fahrenheit. Okay. How we can able to control, or it controlled by the various other parameters also. We can't able to control, but the control can be exercised over the permutation, the temperature and pressure, the fermion concentration, the thickness of the polymer. So increasing the temperature will increase the permutation rate, and similar way the permutation rate of many cases increases linearly with partial pressure. With increasing the pressure gradient, the permutation effect is going to be increased. It is obviously known well while we are impregnating some of the porous material into the water, it is absorbed and the molecules which are all presented in the voids can be easily removed. So that way it allows the liquid particles inside the porous material. That way if you are giving the highest amount of pressure, the pressure immediately increase more amount of liquid penetration inside the polymer. So it is a simple exercise. We can know the temperature, permitted concentration, the thickness of the polymer, which will greatly affect or control the permutation of materials to the polymer composites. Apart from, we have other parameters or um, which we called as other factors which will affecting the permutation consists of these chemical and physiochemical properties. So one is the ease of concentration, and higher the intermolecular chain forces, the higher level of crystallinity of the polymer, the greater the degree of cross-linking, the chemical similarity between the polymer and permutant, the smaller the molecular permutant, the greater the permutation. So these are other parameters. One is the ease of concentration of the permutant. The chemicals that contains readily will permutate at higher rates. The higher the intermolecular chain forces, example van der Waals forces, hydrogen bonding of the polymer, the lower the permutation rate. The higher the level of crystallinity in the polymer, the lower the permutation rate. The greater the degree of cross-linking within the polymer, the lower the permutation rate. So similar way, the chemical similarity between is lower, and the smaller the molecular permutant, the greater the permutation rate. So these are the other factors which will affect the permutation of the material. And the next part, one more phenomena which is called as an absorption of the polymer materials by the liquid. The polymers have the potential to absorb varying amounts of corrodants which they come into the contact, particularly organic liquid substances. Most of them is in a liquid form, it can be easily absorbed. So what will be creating? This will creating the swelling of fibers. You can see that it is a swelling of fibers, it is a water molecule, and micro cracks in the matrices which will allow the liquid to inside the matrix of the composite. So the swelling of fibers, if it is especially in natural fibers, it can easily get it affected apart from the matrix formation. And the diffusion of water through the matrices, it can be weak, and capillary motion of water molecules at the interfaces, and leaching of water soluble substances from the surface to the fiber, and debonding of fiber matrices interfaces. So these are the various effects of absorption of the liquid, any of the organic liquids by the polymer composite. This can result in swelling, cracking, and penetration of the substrate of the lined components. Swelling can cause the softening of polymer, introduce the high stresses, and cause the failure of the bond on the liquid component. If the polymer has a high absorption rate, the permutation will probably take place. An approximation of the expected permutation and or absorption of polymer can be based on the absorption of water. So this is actually interesting phenomena about the absorption property of the polymeric material, which will make a corrosion or deterioration of this property. Why we are studying all these properties? Because these properties are very much important, because the application of the polymer based composites are worldwide. One is start from the food industries, and then biomedical sector, wastewater treatment plant, agriculture sector, pharmaceutical field, and cosmetic industry. So in order to choose the proper polymer composite, we need to be thoroughly study about the various mechanism which will be involved for the corrosiveness of the material. So we need to be select the proper material for the particular application. So these are the factors affecting the incubation performance of the polymers: temperature and pH of the solution, immersion time, hydrodynamic condition, chemical nature of the metal surface interaction, and concentration of the incubator, and aerated and deaerated solutions. Okay. So these are the other factors which can be reduce the incubation performance of the polymer. What is incubation film? Which will reduce the resistance, acted as a resistance to the corrosion. It's called as incubation. So still there are many more researchers about that, how we are increasing or incubating the polymer material, or how you are increasing the resistance to the corrosion. Okay. Up to that, we study about the corrosion behavior of the polymeric materials and how they are getting easily affected by the various other factors. So do you have any clarifications? You can ask from that. Want to get any clarification? Kindly. No? Any clarification? Now, shall we move on to the next one? So, other properties is wear of polymers. So, what is wear? So, wear is actually in four types we can consider. One is abrasive wear, adhesive wear, fatigue wear, and other types of wear, especially in the case of a polymeric material. So, what is abrasive wear? Due to the roughness, roughing between the two surfaces, so one may be the softer and may be the harder surfaces. So, easily remove some amount of metal from the surfaces. So, polyimide sliding against the tri-steel grooves run across the surface of the beer pin parallel to the sliding direction. So, it will remove in the terms of abrasive wear. And what is adhesive? The steel counterspace showing the transfer of film of polyimide formed after 20 kilometers of sliding. It means it is forming the polymer primes. This is the one is the polymer, another one is the hard material of steel. So it will form the polymeric material. Another one is called as a fatigue for the due to the continuous usage of the polymeric materials. It will creating the fatigue wear on the surfaces. Another corrosion is called ferreting and delamination of the material due to some application of and creating the slidingness to the surfaces. So how you know about the abrasive and other wear properties? So the term which is called as a tribological property of material or friction of the polymer material. One is adhesion, another one is called as a deformation. So one is a polymer, another one is a metallic counterspace. When there is a surface contact between these two materials, so that it will creating the frictional forces between them. So Fa is called as an adhesive force, and Fd is called as a deformation force. So Fa is depend upon the shear resistance of the material and area of the contact, and for the deformation it will depend upon the yield strength of the material. So the W's is a shear stress required to produce a sliding between the roughing surfaces, and sigma y is a polymer yield stress. So A R1 and A R2 the real contact area of the junction between the two surfaces. So from that you can know about how much amount of forces are required to creating adhesion or deformation of the material during the wear. And some of the factors which will be need to be studied. You know about the wear property of the material. One is called as a sliding speed, and for coefficient of friction. So the factors affecting the friction and wear of the polymers are the sliding speed. The friction coefficient versus sliding speed for some industrial polymers and specific wear rate of the tri-sliding polymers. With increasing the sliding speed, the wear rate is actually drastically increased. These are cases for the sliding speed. So how it is impact on the wear resistance. The next one is actually called the sliding temperature. Low thermal conductivity of thermoplastic polymers is an important limitation of the sliding application. So the mechanical property of the polymer show the transition from the glassy state into the rubbery state upon the heating. So due to friction, the enormous amount of heat are generated. But for the polymeric material, because of its low thermal conductivity of especially thermoplastic polymers, the important limitation is sliding application. So where interfacial temperature is developed by means of starting from the environmental temperature to that and other factors which will be considering as the mu is called as coefficient of friction, and Fn is a normal forces, and d is a sliding velocity, and L is a semi length of the sliding body, and K is a constant factor, thermal conductivity of the material, and all other aspects we need to be considered here. So this is a real scenario of sliding temperature, how it impact on the wear of the polymer. And the next one is a counterface surfaces, where counterface surface roughness is increased. The increase in counterface surface increases the wear rate of the material or wear factor of the material. So initially it shows a lesser amount and it's going to be increased drastically well because of um, the RZ value of the mean peak to peak value of the material is increase in the coefficient of friction. In polymer metal sliding, as the counterface roughness decreases, the friction coefficient of the polymer decreases. But after reaching the minimum value of RZ, that is mean peak to the value, a further decrease in the roughness causes a high friction. So adhesion forces become dominant factor, whereas the highest surface roughness abrasive wear privilege. So this is relationship between the counter roughness to the wear of the polymer. And the third one is called as an applied load and contact pressure. At high loads, the thermal softening of the polymer and plastic deformation, interaction of the dominant role in determining the real area of the contact. So the relationship between the friction force and applied normal load F equal to mu L power n, the friction factor is directly proportional to the normal reactive load, so that highest amount of load increases the highest friction rate. The relationship between the wear factor and the load and maybe depends on the exponential form of. So wear factor is exponential form, it will increases in the exponential manner. Okay. And the humidity and surface wettability of the polymer. If the water molecules are diffused readily into the free volume of the amorphous phase of the polymer, leading to the plasticization, swelling and softening, whatever we studied in the earlier corrosion, corrosion of material because of absorption. So it will creating or reducing the property of the material. The wear property is also going to be drastically reduced. So what are the effect of washing action of the counter surfaces? Very easily remove the surfaces from the material due to the surface friction. So water might increase in the chemical corrosion wear of the metallic counter surface. So how it is increasing? It's creating the two effect. One is called as an hydrophobic effect, another one is called as hydrophilic effect. So hydrophilic effect not wettable, hydrophilic is wettable in cases. The increase in the polymer with respect to the water lubricating resistance in hydrophilic nature. So it really depends upon the contact angle. So highest contact angle reducing in wettability, the lowest contact angle increasing the wettability. And other factors which are affecting the wear of the polymer is fluid lubrication. It may be in external lubrication or internal lubrication. In external lubrication, other parameters like boundary, hydrodynamic, elasto-hydrodynamic effects. The formation of absorption and chemical reactor layers, the higher the speed and the flatter the geometry, the thicker the full form. Occur at higher pressure when surface deformed within the elastic region. There could be a different effect in the internal lubrication of the polymer and the friction and wear due to the modified mechanical property of the surface energy. So today's scenario, we are increasing the properties by means of adding some additives or agents, reinforcement, which will also going to be reduce the wear property of material, or sometimes it also going to be increased. If you are using a graphene as a filler material, then the wear properties are highly increased. But if you are using the other abrasive materials for increasing the property of the polymer composite, it will deteriorate the wear properties with increasing the volume fraction. So this is the reference we follow. So if you need, we can directly go through this and you get some idea related to the wear as well as the corrosion of the polymeric material.